This video is to go over finding the equation of a tangent line algebraically. So let's think about, let's review what the secant and tangent line. So the secant line is this guy that goes through 2 points on a function. In this case, function is x cubed minus 2x plus 1, which is from page 198. And the tangent line is this guy that is just touching a straight line that just touching the function f of x, which is x cubed minus 2x plus 1, just touching at point 2, 5. So how do we find the equation of this? So the secant one is that, so secant line crosses at x equals 2 and 3, so that tells us that x minus 2 and x minus 3. Tells us that we can come up with that. That is x squared minus 5x plus 6. So we're going to divide the function f of x, which is x cubed minus 2x plus 1. If you divide it by that, minus by 5x plus 6, then we'll have x, which is x cubed minus 5x squared plus 6x, subtracting 5x squared minus 8x plus 1. So 5 goes here, so that 5x squared minus 25x plus 30, subtracting 17x minus 29. So this is the equation of the secant line, which is this guy. So let's label that. That is 17x minus 29. So that's the equation of it. You know what? Let's just put g of x equals. Okay. So how about this tangent line, right? So the tangent line is that if this point a 3, 12 goes closer and closer just another line like that. Let me move this. Oh, that doesn't move. Okay, so let me just erase this line. And if you have a point here and very close to that one, and if you see this, if this point goes right on top of A, that's going to be 17x minus 29, which is g of x. But if this point goes closer and closer to point B, and if it's right on top of B, that's going to be the tangent line. So we had x equals 3 up here for the secant, but though that line goes closer and closer to x equals 2, therefore, instead of having x equals 2, 3, we should have x equals 2 and 2 for the tangent line. So that means we have x minus 2 times x minus 2, which is x minus 2 squared, which is x squared minus 4x plus 4. So if you think about the tangent line, the tangent line is kind of like special secant line. So we're just going to do the same exact thing. Instead of having x squared minus 5x plus 6, we're going to divide it by x squared minus 4x plus 4, which is x minus 2 squared. So we have x cubed minus 2x plus 1 divided by x squared minus 4x plus 4. So we have x here, so we get x cubed minus 4x squared plus 4x, subtracting Now we get 4x squared minus 6x plus 1. So we should have plus 4 here. And 4x squared minus 16x plus 16. Subtract. And we get 10x minus 15. So the equation of the tangent line, which is this guy, is h of x, y equals h of x, which is 10x minus 15. Okay? So let's go back to the theorem. The theorem says, the theorem 3.4 says, if you divide the function f of x by this guy, which is x minus a and x minus b in the generalized version, where does this a come from and b come from? That comes from these, right? So if you divide it by that, whatever the remainder function, which is r of x, is going to be the equation of the secant line. If you divide it by x minus a squared, which is this guy in this case, if you divide it by that, then whatever the remainder is going to be the tangent function. That's the theorem 3.5. And that's how